So the game is 2013 question 2, so it's a Bayesian Nash Equilibrium one. And so I will go directly solve this Bayesian Nash Equilibrium. So the strategy, so the way that I'm going to solve it is going to be slightly different from this solution. I'll just solve it like how we did it in the tutorial. Because in the solution, there is that trick of the maximum expectation thing, which cannot be applied to the Bayesian Nash Equilibrium game in general. So I will still do it the slower but more general way, so that you can see how it works for different questions. So the first step is finding best responses for player 1. It's a continuous action thing, so we take the derivative first order condition, which gives you E2 is minus 2E1 is equal to 0, so we have our best response function. For the first player, given there are two types of the second player, so I should probably write it like how we usually write it. So I'm best responding to two people because there are two types of the second player. So I am responding as if I'm facing two opponents. And the best response is given by solving this thing is 1 plus 6 E2H over 2 times the probability of meeting the high type, and plus 1 plus 6, the same thing, times the probability of meeting the low type. So then we simplify this as usual. So this is 3 E2H plus E2L divided by 2. So now we have our best response function. I should probably move it up a bit. Okay, and the best response function of player 2, there are two types of, there are two types of player 2. So the 1, I can play either 0 or 1, or do 1 or 0, and it's according to our payoff function here, which I know you cannot see. So this thing. So I'll probably say if this is larger than 0, then I will invest. If this is smaller than 0, then I will not invest. So it's easy to write that down. So if E1 is larger than the high type cost, CH, which is number, 11 over 3, and if E1 is smaller than 11 over 3. So you can probably guess the other one is exactly the same. So we have 1, 0. If E1 is larger than, there should be an equal somewhere. I'll put it here. C low, which is 7 over 3. And this is if E1 is smaller than 7 over 3. So now, as in the tutorial, we have 3 best responses. We can start guessing all possible Nash, which is not a lot, and then check whether each one of them is a Nash or not. So the possible Nash, we guess. The first one is hard to guess because it's a continuum, so I don't know what you all play. So the second one is easier. So I can either play 0, 0, 0, 1, 1, 0, or 1, 1. So the first one means what the high type of player 2 will play. The second one means what the low type of player 1 will play. So then we can go back to, given this thing, we can find the best response using this function, right? So we have our function here. We apply this function. So I think it's easy to compute all of them. If it's both 0, then it's half. If one of them is 0, then it's 2. If both are 1, then it's 7 over 2. So now let's check that we now know that these things are best response to this pair. Now we know we want to check whether each one of them is best response to this half as well. So the first one, let's see. So is 0 the best response to a half? So we're checking this condition. So if half is less than this, then 0 is the best response. Yes, it's good. And the second one is half is less than 7 over 3, then well, the first one is a Nash, so it's good. It's a Nash equilibrium. Probably we're going to stop here, but we should still do the rest. Is 0 the best response to 2? So is 2 smaller than or equal to 11 over 3? Well, guess it is. And second, is 2 larger than? So now the second player, low type, is playing 1. So I need this condition to hold. I mean, not half. 2 must be larger than or equal to 7 over 3. Which doesn't look right, which I don't know what that number is, but it doesn't look right, so this is not right. So probably this is even worse, because we need 2 to be larger than something that's even larger, so that's not working. The last one may be okay too, let's see. So it's 1 best response to 7 over 2, so we need 7 over 2 to be larger than this. 7 over 2 to be, so I'll write it here. So we need 7 over 2 to be larger than 11 over 3. That one is kind of hard. This is 3.5. No, let's do this as if we were in elementary school. Maybe 6 over 21 to be larger than 6 over 20. No, that's not right. So the second guy is okay, the first guy is wrong. So we only have one Nash equilibrium here. That's the only one we want.